So when I start off with this lesson, you might begin it a little bit confused, but when we get about halfway through it, you're going to wonder why you were even confused in the first place. So with this lesson, it is explain the size of a product and relate fraction and decimal equivalents to multiplying a fraction by 1. It sounds ridiculously confusing, but it's not as bad as it sounds, okay? So, I'm going to start off with 2 halves of 3/4. So, the first thing I want you to look at, when you look, let's sit on my mouse when I do this. When you look at this, what is the first thing that you see when you see 2 halves of 3/4? But Diamond, what do you see? Okay, and you guys might agree with this. She says 1 whole. When you see 2 halves, you should automatically, hopefully, notice that 2 halves is equal to 1 whole. So what should our answer be equal to?
1/4.
Not 1 and 3/4. It should be equal to 3/4. Because when we're taking a fraction of a fraction, what do we do with them? We multiply them. 2 halves times 3/4. What is our multiplication rule of 1? Any number times 1 is that number. It stays the same. So 2 halves times 3/4, we should get 3/4. So if we look at it this way, this is 1 times 3/4, we get 3/4. Not 1 and 3/4, that's adding. This is 3/4. We're multiplying. Oh, 3/4. It is easy. But if we do it the way that I was saying before, where you multiply straight across, say you didn't automatically know, okay, that's 1, and you multiply straight across. 2 times 3. Because some people don't automatically know it. 2 times 3. 6. Please stop ticking that. 2 times 4. 8. 6 eighths. You can and you should. So, simplify by 2. You get the same answer. So, what you should see is that if you multiply a fraction by a fraction, sometimes you get the same answer. Because if my fraction is equal to 1, you get the same thing. Sometimes my fractions get smaller, but sometimes they stay the same. In this case, it stayed the same. So this relates to what we're doing today. Okay. We're going to try another. So what if I have 3/4 and I multiply this by 5/5? Now we already know that our answer is going to end up being 3/4, but we're going to do it the other way. We're going to do our regular steps for multiplying fractions. So what should we get? 15 20ths, because we multiply our fractions straight across. 15 20ths. Okay, so so that would eventually become that 3/4. But we're not going to worry so much about simplifying our fractions today, because we're working on taking our fractions and turning them into decimals. So if you remember when we were doing our fractions and getting them towards decimals, what did our denominator need to be? A power of 10. We needed it to be a 10, a 100, a 1,000. So we don't really want to simplify them because we need them here. So if we simplify them, then it kind of makes it kind of odd. So our goal is to take our denominators and get them here to our 10, to our 100, Johnny, put that up, to our 10, to our 100, to our 1,000. So that's what we're going to be working on today. We're going to take our fractions, multiply them by something that's equal to a 1. Because remember, what we do to the bottom, we do to the top. So whenever we've been doing our equivalent fractions, haven't we been doing multiplying by something that's a 1? What we do to the bottom, we do to the top. That's multiplying something that's a 1. We've been doing equivalent fractions the whole time. That's what we're doing today. So now we're just going to make it to where we can turn it into a decimal. It's what we've been preparing ourselves for. So now we're just taking it an extra step.
So I guess this is 20 probably 100.
So now we can take this. We could have taken this. I'm going to show you how to take 3/4 or 1/4 or 5/8 or a fraction. And I'm going to show you how to turn it into a decimal. I'm going to show you 2 different ways. Both ways work. One way is this way, the engaged way. And one way is the way that I learned when I was in school. They both work. Because sometimes the engaged way is really cool, it's really easy. But sometimes the engaged way, I don't want to say it's harder, but sometimes it just, I can't wrap my brain around it sometimes. And so then I go back and go, okay, I'm going to do it this way today. What? So, because sometimes I just can't get there. I like this way. It works. So, I'm going to try. Let's clear this off. It's too cluttered. Say I have 1/4. And I have to do getting to a power of 10. Because to get to a decimal, I have to do a power of 10. This will make sense in a second. I'm going to begin with the end in mind. I need to get a power of 10 in my ending denominator. Can I do from a 4? Can I go to 10?
No.
Evenly from a 4?
No.
Can 4 go to 10?
No. No.
No. Evenly.
Oh, no.
Can 4 into 10? I have a remainder. Does it work?
No.
No. So let's see, can it go into 100?
Yes.
So my ending denominator is 100.
I thought you changed it on, but I was thinking, like, what if you change it? Oh no, because there's none of that.
That's not a very pretty zero. So what did I have to multiply by 4 to get to 100?
25.
25. So what I do to the bottom,
We do the top.
I do to the top. Does that make sense?
Yes, ma'am.
You see what I did?
Yeah, a little bit.
Did you say no? Okay. That's only the first time I did it. But what part of the no? What part is the no?
Where you handle the 25 and
This or this? I was trying to see what did I have to put here, so I had to divide 4 into 100. You might be a fan of the other way I did it. So give me just 1 second, okay? I'm going to do it another way, and I think you're going to like my other way.
I didn't do the top.
Okay? So, and it's only the first time I've done it. So, sometimes it takes me more than once, okay? So, 1 times 25.
25.
So now, I need a decimal. We're not simplifying. If I simplify it, I'm going to get this again. I need a decimal. So, 25. How many places am I moving my decimal in? 2. Start here. 1, 2, bang. 2500.
I get that.
So, what's that? Yes, ma'am.
Where'd you get the 2 from?
This? This 2?
There's the 2 to
2 zeros. Mr. Dole. So, Jeremy, my other way, and this is the old school. Old school like the old school. And this is how your calculator does it. Fractions are basically division. Dividing the denominator into the numerator. Do you agree? 4 dividing into 1. Can 4 go into 1?
No.
But when you're dividing these things and you're trying to get a decimal, you are not allowed to have a remainder. That's the trick. You cannot have a remainder. So what do you have to have? Decimal. Then you have to add
A 0.
a 0. So 4 is not going into 1 anymore. 4 is going into 10. How many times can 4 go into 10? 2. Oh, look at that. So, I mean, this way is not bad. But then there's this way too. I do. So since I can't have a remainder, add another 0. 4 goes into 20. 5 times. And this is why sometimes when you divide things on your calculator, you get numbers that are this long, because it keeps throwing those zeros on there until it gets nothing. Or you get E's on there because it was either way too long or it just kept going. Or if you divide 3 into 10, you get 0.3 or 3.333 E because it goes on forever. So it'll either continue on until it gets to the end and you have no remainder, or it just continues on forever. Yes, sir. It'll continue on until it either finishes out or it'll just continue on forever. But it'll just keep adding on. You just keep doing zeros until you finish. But when you're doing decimals, you don't have a remainder. It wouldn't be 2/10 with a remainder of 2. You would just add another 0 and bring it down. I mean, it's whichever one you prefer. They both work. You still get the same answer. But you have to be able to divide it correctly. And so it's whichever one you prefer. They both work.
Eight. Two.
Because 4 goes into 10 2 times. 2 times 4 is 8. I'm going to do another one. It's only the first one. Oh no, I do more than one example. Really children. Okay. So if I have 1/5, what is the smallest power of 10 that 5 is going to go towards? 5 is not 5. So 10 makes the most sense, correct? So I'm going to put it over here. I'm not putting it here. It's 5 times what can get me to 10. So 2. What I put on the bottom, I put on the top. 1 times 2 is 2. So I need to write this as a decimal. So I'm going to write my number. How many decimal places? 1. Moving 1 time. 2 tenths.
That can have as many zeros on.
Yeah, we can go forever, but why write on this? Just too much work. So if you chose, you could do 5 divided into 1. Can 5 go into 1? No. You'd write the decimal. You'd write your zeros. 5 doesn't go into 1, but 5 can go into 10. 2 times. 2 times 5 is 10. With no remainder and you're completed.
Wait,
Either one. Sorry.
what if there's not a 1?
If there's some, if you have a different numerator? Good question. We're going to get there. Then you would multiply it by whatever's there.
But it wouldn't.
Can you give us one?
I will. I shall. Okay. So, how about, I'm not going to give you that one. So what about if you had 2 tenths? Oh wait, no, not 2 tenths. Why did I do that? That was part of something I was looking at. I know, I was looking at something that's silly. No, it was part of a problem. That one's a little bit harder though. You want to try that one. 1/8. What is your power of 10 denominator?
1,000.
1,000. Now, I watched Ladina solving it, and she solved it the exact same way that I would have done it. So, kudos to you, girl. Because my first thing would have been to try 100. And just because, you already know that 8 can't go into 10. So, down here, I've been like, I don't know what to put right here. And I'm not in 5th grade. I've been like, I don't know what to put here. So, she did the exact same thing I would have done. I would have been right here, 8 into 100. She did the same exact thing I did this morning and last year. So 8 into 10 goes 1. And then you have 20. And then you have 2, that's 16. And you go, oh man, I can't have a remainder. Oh, so then what are you stuck doing? Adding another. So then it had to be 1,000.
Oh my gosh, I just did all that work. I could have just done one.
So
I just did it, and I did that at a row, and I'm like, okay, I can't do that because it's going to have to go transfer stuff, so I didn't look at it.
So that's what it was, where it was 125 over 1,000, so you have 125 thousandths. 1, 2, 3. To the decimal.
I should have used the volume.
Or you could have just done 1 divided by 8, and you have the decimal, and then you would have had to just add a 0 at a time and divided it. And I mean, you end up doing, twice the work. Add another 0, 2, add another 0. Well, I mean, why add a whole bunch up there and then end up not having to use them? I would just add 1 every single time you gotta go.
I'm gonna start doing the 8. I'm gonna start doing the 8 divided by 1. So that was easy.
So, either way. Now, the question is, what would your answer be if it were 2 8s?
It would be 125 times 2. 125. 250.
Wait, let me work that.
250,000. 250 over 1,000.
Yes, ma'am.
2 8. It was 2 8. It would be 1/4, and then 1/4 is 25 over.
That's a very neat way to rationalize it. I didn't even think about it that way.
That's not 250.
The way Lexi figured it out, see, I didn't even think about it that way. I just took my answer and I doubled it. But Lexi said, doubling that would be 2 8s, and 2 8s is 1/4, and 1/4 was 2,500. Well, I also know that this doubled will be 250. So, if we have 2 8s, it's 2,500 behind the decimal. So, either way. Now, a couple of mine this morning, they were trying to double the denominator, they were trying to double everything, and the only thing that we were doubling was the numerator. You weren't doing anything to the denominator. So the only thing that you were doubling was this.
They were smart enough to not fall for the tricky setting.
Yeah. Yeah, we're pretty smart. Okay, I wasn't trying to trap you. Okay, so what if we had, check my time here, 1 and 1/20th. What do you, it's not as bad as you think it is. What do you think? Is there anything in this problem that you think we wouldn't really have to worry about during the middle of our problem? Zach?
Wait.
I'm sorry. You see, when y'all have your hand up when I'm not finished with my question, kind of throws you off. Is there anything in this problem or anything in this number that we can kind of hold off to the side and kind of go, I don't need to worry about that right now. I can kind of hold on to it later until I need it for my answer. The 1. The whole. I don't need it right now. The only thing that I really need to worry about is my fraction. This 1 whole is like $1. It's not part of a fraction. It's already the whole. I don't need it. I do need it, but I don't have to mess with it. So as part of my answer, I can just kind of put it right there. It's in front of the decimal. I don't really need it right now. I need it, but I don't have to need it for the problem.
You don't have to multiply all of it plus that.
I see now.
I need it for my answer. I don't need it for the problem.
Oh, I see where you're going.
So this, the 1/20th, needs to be made into a decimal. So 1/20th. what power of 10 am I going to go to?
10.
1. I want to go to a 10.
Oh, I've got 2.
No, it can go to 100.
Girl, it can go to 100 by multiplying by 5.
I think 1.
5. If I multiply 20 by 10, I'm going to get 2,000 or 200 or something really weird that I don't need. 200. I don't need that. I'm only going for, what's 2 times 5? 10. 10. So 20 times 5 is 100. Don't make it harder than it is. So 1 times 5 is 5. 100.
1.05.
Because 5 with 2 decimal places. 1, 2.
And the 1 is in front of you.
The 1 is in front.
1 in 500.
1 and 500. Like this is 1 and 1/20th. 1 and 500. 1 and 500. 20 into 1. 20 can't go into 1. 20 can't go into 10. 20 can go into 100 5 times.
And where's the one
The 5 is on the.
That's only 500. So how are we supposed to have that one bit? Oh,
Because it's one whole.
what? So when you do the decimal version, I don't see where your 1 is coming from because you did all that and got 0 on the bottom, but it's only 500. Where's the whole going? Here.
If you do this, 100 and 100, it's 0 the whole way, so how are you supposed to put your place in there?
That 1 is that 1.
Oh,
This one is 20 into 1.
okay.
Does that make sense? I wasn't even messing with this one. I was doing 20 divided into 1.
Oh, okay.
This one, I wasn't even messing with it.
Okay.
Okay. Okay, now, on number 1 that's on the top, it says to fill in the blanks. A is already done for you. So it's got 1/4 times 1. Now this is what we were doing on those very first examples. 1/4 times 1 equals 1/4 times 3/3. 1 is equal to 3/3. So then it's equal to 3/12 because 1 times 3 is 3, 4 times 3 is 12. So on B, they've got 3/4 times 1, and then they've got 3/4 times a blank because they want to know what fraction would go in that blank that would be equal to 1 that would make your final fraction be equal to 21 over 28. What could you multiply by 3/4 to make it equal to 21 over 28?
7.
That's not a fraction. That's a fraction. 7 sevenths because that's equal to 1 and that would make 3/4 equal to 21 over 28. Does that make sense?
Yes.
Then you do the same thing for C. That's not how you say that. Yes.
Oh, I was confused at first. Now. Alright, so
But really, all they're saying is use words to compare the size of the product to the size of the first factor. This is the product. This is the first factor.
oh,
Product is the answer you get when you multiply. So How could you compare the size of the product to the size of the first factor?
Multiply it by 3.
How would you compare them? In any of them, A, B, or C, how would they compare? Jeremy? On any of the examples that we did, any of them, how would your answers compare to the very first number? Because
In 4.
Because 4 times 3 is 12, and 12 times 1 is 12, and
they are equal because we multiplied by 1. Every single time we're multiplying by a fraction that's equal to 1. We multiplied by 3/3, 7/7, 5/5. We multiply by 25 over 25, 125 over 125. We're multiplying by 1. So our product is equal to our first factor. Every time. It's equivalent because we're multiplying by 1. It looks bigger, but it's still equal.
But she could still simplify it.
Because when we simplify it, we get the same exact thing.
Yep. But if you try to definitely simplify.
So you could say that the product is the same. The product is the same as the first factor because we are multiplying by 1. So A and B are already halfway done for you. So you've got 1/4, and they're trying to get to that power of 10, which should be 10, 100, or 1,000. You can continue on, but that's probably as big as we're going to get. So 4 times 25. 4 times 25.
4
Yeah, 4 quarters.
It's 100. It's 100.
It's 100. 1 times 25. So then if you have 25 over 100, you have 25. Move that decimal in 2 places. 1, 2. 25 hundredths. That's all you have to do.
I just went ahead and expressed it as a decimal. So you do like fraction.
4 times 25, you go like diagonal that way, and then 1 times 25 diagonal.
No, we do not cross multiply in here, ever. We go straight across every time. I have never cross multiplied in here, ever. It has always been straight across. Never cross multiplied in here, ever. The only time that I've ever done this kind of thing is when we've simplified, when we've divided it. And we're not doing that right now because we're not simplifying these. 4 times 25, 100. 3 times 25, 75. Decimal, 1, 2. Yeah. What power of 10 would you go to with 5?
10.
power of 10? I shouldn't have heard 2. What power of 10? 10, 100, or 1,000? 10. So I'm going to go ahead and write that. So then 5 times what gives you 10? 2. So what you do to the bottom, you do to the top. 1 times 2 is 2. So I write my 2, and then I move my decimal in how many zeros I have. So I start here, 1. It's not as hard as you think it is it? No. Hold on a minute, just a second. And so again, with 5, it's okay, she thought we were wrong already. So 5, again, we're going to that power of 10. 5 times what gives you 10? 2. 4 times 2 is 8. Bring that decimal in one place. So 4/5 is equal to 8/10. Were you writing this down, Parker? I don't see a pencil in it until now. Okay, so I'm going to do it both ways because I think some of you might have done the division way, and like I said, it's not wrong to do it either way. There's the fraction way and there's the division way. It doesn't matter as long as you get the right answer. And I've said that since first quarter. Doesn't matter how you solve it, just do it right. They work best when they're on your face. So 1/20. So times something equals something that will turn into a decimal. So we're looking at what power of 10 will 20 become? So can 20 become 10?
No.
No. So will it become 100?
Yes.
Yes.
20 times 5.
So 20 times 5 will become 100. So then the 5 will go on the top also. 1 times 5 is 5. So then we have 5. Decimal comes in 2 places. So it starts here. 1, 2. So it's 500. It should look like that. Now, don't let the fact that there's a number in the numerator other than 1 throw you off. It's just a number. Marco, are you looking or are you playing with something? Are you paying attention or are you paying attention to what's in your hands? I know the answer. I'm just wondering if you know the answer. So, again, since we had 20, we're going to 100. We know that it's going to take 5/5 to get there. So 27 times 5. I'm still going to do the same step. So 27 times 5. So 5 times 7 is 35. 5 times 2 is 10, plus 3 is 13. 135. So 135. Decimal starts here, goes in 2 places. 1, 2. So 1 and 35 hundredths. So if we were going to do this with the division instead of the fraction way, which you can totally do, 20 divided into 27. Well, 20 can go into 27 one time. 1 times 20 is 20. But we don't want remainders. You don't have to do this. If you're doing the fraction way, you don't have to write this down. I'm just showing it because I know at least one person who did the division. So then I add my decimal, add my 0, bring it down. 20 can go into 73 times. 3 times 20 is 60. That leaves me with 10. Well, still, can't have a remainder. Add another 0. Bring that 0 down. 100. Well, I know that 20 can go into 100 5 times. Now I have my 0, and I have my answer, which happens to match that.
Yep.
27 times 5 is 135. Then you might have multiplied wrong. So whether you do it this way or that way, seven fourths times something equals a fraction that you're going to turn into a decimal. So whether we're doing 10, 100, or 1,000, can 4 evenly become a 10?
No.
No. But can 4 evenly become 100?
Yeah. They go on 25.
It goes in 25 times. It takes 4 quarters to make $1. So 4 quarters to make 100 cents. $1.
You did this wrong.
7 times 25.
It's 150. Because a dollar is.
This is 35.
I didn't get it.
Because it's 7 times 25. Because 7 times 5 is 35. Write your 5, carry your 3. And that's 14 plus 3 is 70.
Yay.
175. Bring that in 2 spots. If I had 7 quarters, this would be $1, and 3 extra quarters would be $1.75.
See, I thought the dollar was 5.
Would you stop? Damn it. Yeah, because shaking the eraser really made it become an eraser. Why was there space it? I didn't. But you know what? That's the second time it worked. Or I could divide 4 into 7. 4 goes into 7 one time. Left with a remainder of 3, which I can't keep.
So add a 0.
Add my decimal first. Yep. 0. I was listening to you, Jacarius. Now it's 30. Now if I do 6, that's only 18. That's not 18. That's 24. 7 gets me closer. That's 28. Which is 2. Still can't have that. I was thinking 3 when I said 18. Silly me. That's 20. Why did I write the 0 up there? Good grief. I have lost my mind. Oh my stars. Okay, 7, 5, 20. See, I was looking over here, I think, when I did that. I don't know what I was doing. 175. 1 and 75 hundredths.
So smart.
You know, my mom said I was smart. No, she never did tell me that. Okay, so she said, your brother made an A on that. Why didn't you make an A on that? Okay, so 1 and 75 hundredths. So that was G. Nope. I divided 4 into 7. So that's G. So what kind of friend is that? Okay. So you're the one telling me to step on her, so where's the harassment there? Okay. So 8/5, what power of 10 are we shooting for?
100.
We're trying to keep this as small as possible. Okay, so Aim for the stars. Aim for the stars. So we're going to multiply by 2. 8 times 2 is 16.
One.
So
This is this.
we have 16. We're going to bring it in one spot.
Oh yeah. I got
1 and 16.
I got them all right.
So if I show the division, 5 into 8, well 5 can go into 8 one time. And then we're left with the remainder of 3. Well again,
Add a decimal.
yeah. Bring that down. 6. So again, you still get the same answer. Good. So forever. What?
Stop flicking her wrist. Just turn it.
Okay. So 24. 25ths. So again, times something's going to give me something. We got 25. What power of 10 are we going to go for?
100.
100. We're going for 100 because 10's not going to work. So 25 times something gives me 100. 4. So we have 24 times 4. So 4 times 4, 16. And that's 9. 96 hundredths. So 96, bring it in 2 places, gets you right there.
Good job, Dad.
And y'all thought this was going to be hard when I did the very first problem, and you were like, what? And now you see it's not hard.
It's not hard at all.
And Miss, I really want to cross multiply. Yeah, no. So for this problem, 24 25ths, the division would just be really, that would actually be harder than just doing it this way. So sometimes the division is easier, sometimes the division is harder.
It's kind of like sometimes I want to be easy, sometimes I want to be hard.
It's only hard when I don't work it, I just copy, but when I do it myself, it's easy.
So let's just not copy.
Okay.
Okay, so 50 times something equals something. Our power of 10 denominator, we're just have 50.
Oh, 100.
100. So if we take 50 and we double it,
You get 100.
we get 100.
Yeah.
So 93 times 2. 2 times 3, 6. 2 times 9, 18. 186.
You gotta make that a whole now because it's way too big. So you gotta
186, bring the decimal in 2 places. 1, 2. Easy. Unless, of course, you're not paying attention because you're playing with your pencil.
Wait, which one are we on?
That was J. It has nothing to do with the fact that you're sitting there playing with your pencil. I'm not asking. I'm telling you that you're playing with your pencil. Okay, so 2 and 6 25ths.
You don't have to worry about it.
Do not have to worry about the 2. I might just go ahead and pull it down here for 2 and. Because all I need to worry about now is 6 25ths.
Yep. It's 100.
Can't do 10. Gonna shoot for 100. So multiply by 4. 6 times 4, 24. 24 hundredths. So 24, bring the decimal in 1, 2. So your final answer, 2 and 24 hundredths.
Oh yeah.
Yeah, so you can't forget about it, can you? Because it was there. 2 and 24 hundredths. Mm-hmm.
Oh, I totally would have forgot that.
Yeah. Gotta be the annoying big brother, because I don't know.
Oh,
the
it's
little
like
brother.
it's like my annoying cousin.
Yeah. Do not forget about the whole number. 3 and. So this is 31. See, it's hard to read on here. 31 50th. So we're shooting for 100. So we've got to multiply by 2. So 31 times 2 is 62. 62, moving that decimal in 2 places. 1, 2.
3 and
62.
Oh, and you have to add that whole number. I got 3. You have to add the whole number.
Wait, what?
I did. I wrote it already. When I was writing my answer, I went ahead and brought it down. That's why I scribbled it out. I went ahead and wrote it where my answer was going to go.
Okay, I was looking at that one. Carrie was blocking.
I wrote my answer down here, and then I wrote my little answer here so that I would make sure that I put my decimal with my numbers in the right place. Because when we did our practice problem, when it was 500ths, we had to add that 0 in there. Because sometimes, like, people might write their whole number with, if it were 3 and 500ths, they might put 3 with a decimal with a 5, when that's 3 and 5/10, because they forget to put that 0. So I went ahead and wrote my 3 with my decimal, figured out my decimal here, and then I smooshed them together down here. Does that make sense? Yeah, kinda. I grabbed the whole number, threw it down here. Figured out this, put it here. Grabbed my decimal, threw it down here where my whole number already was. Smashed them together. Made me a whole decimal sandwich right there. Threw them together. Okay. So I'm only going to spend 1 bit on the back because we've got to do 1 bit on the social studies, and that's all I'm going to do. Okay? 1 problem on the back. On number 3. It says, but it's really not. It says, Jack said that if you take a number and multiply it by a fraction, the product, what do they mean when they say product?
Answer.
The answer you get when you multiply. That the product will always be smaller than what you started with. Is he correct?
No.
Explain. It's say why or why not. Explain and give at least 2 examples to support your thinking. So you can't just say no. Actually, you should know.
Yeah, because you did that one thing times the 1/2, and it was the same thing.
That's why he's wrong.
Yeah.
Because he says always. Is it always smaller? No. Sometimes it is. If I have 3/4 times a half, if I take a half of 3/4, then yes, it's smaller. If I take a half of a half, then yes, it's smaller because it got smaller. I know you're like, what? You just threw numbers at me. So if I take there's a half. And I just took half of a half. Did it get smaller? Yeah, it just became a 4th. It got smaller. Okay? So he's saying that every time I multiply a fraction by a fraction, it's going to get smaller. What he's saying is every single time, always, never fail, every time you multiply a fraction by a fraction, your answer is going to be a smaller fraction. And you guys are saying no, and I agree with you that he's wrong. Because if you look at what we were doing on the front, were our fractions smaller? Were they bigger? Or were they equal? They were the same thing. Because we were taking, I can even make those where they're not faded by light. If you take, say, a number, 3, and I multiply it by a fraction,
It's the same number because two halves equals
Divided Oh, because it's 3 times 1 whole, which is basically going back to the whole.
right? So I'm multiplying it by a fraction that's essentially equal to 1.
Yeah.
2 halves is equal to 1 whole, but it's still a fraction. He's saying that if I multiply it by a fraction, the product will always be smaller. Is it always
You
smaller?
can say no because when you do blah blah blah, it's
Exactly.
small.
So is it always?
No.
No. Is it sometimes?
Yes.
Yes. So sometimes but not always. If you multiply by a fraction that is equal to 1, the product is the same. Because if I had 3 times 5/5, I would still get 3.